Hello, my name is Jamil Hussein. I work in the technical marketing team at Xilinx headquarters. Today we're going to talk about the KC705 evaluation board and the Kintex 7-2L low power device. We've got the board set up right here. We have a design running that has a DDR3 memory interface. We also have a decryption and encryption block that's sending data through the GTX transceivers at 6.25 gig. We've got one channel here on the SMA cables and 3 channels on the internal loopback. We're going to go through some of the power measurements on this board, which is built into the KC705 board. We've got power measurement capabilities. It's great for doing evaluations on how much power your design is actually consuming. Through the digital power regulators, we can actually read the data out of this USB cable and onto this GUI, onto the screen. We're able to display VCC int, VCC aux, the I/O rails, and the MGT rails. In the current state of the design, everything is turned on. We're in its highest power state. It's consuming about 10 watts. What we're going to do is turn on some of the features, and we're going to see how much power is actually reduced real time on the board. The first one we're going to turn on is the intelligent clock gating. This is a feature in the software that dynamically can gate off unnecessary toggling in the design. We've had this feature available for a few generations now, and typically you actually have to run a different design with these software options turned on and load a new bit stream. For demonstration purposes, we have a custom enable, and when I press this button, it actually enables all of the logic that was added by the software. You see a pretty significant reduction on total power here. This is actually a little bit more than what we'd normally expect. We're seeing about, on average, 20 to 30%, but because of the nature of the design, it's a decryption and encryption block. There's a lot of glitching. The power gating technology allows you to take a maximum advantage here and see a pretty significant reduction. If we look at the memory interface now, this is a 72-pin DDR3 interface. I'm just going to change the scale and change the displays so we get a better idea of what's going on. Remember, the baseline power was about 10 watts and it was about 50 degrees C, maybe a little bit more than 50 degrees C. Right now it's in a read-only case. When it's in read-only, the input buffer is on, the DCI termination is on because it needs to input the data from the memory. Now if we go to read and write, the 7 series devices, the Kintex 7 and all the 7 series devices, have the ability to dynamically turn off the DCI termination and the input buffer, the reference receiver, when it's being output to the memory. So in the read-write case, you're saving some power from the read-only case because you can turn these off dynamically. On the write-only case, you save even more power because instead of being 50% on, 50% off, it's off 100% of the time. So remember, if you don't have these features, you're stuck at about 4 watts and you're stuck at this top line here without any reduction all of the time. Now, if you switch to a bus idle mode, if the memory interface is idle for whatever reason, you can manually override the DCI and iBuff signals to get a lowest power standby state. Again, if you don't have these, you're stuck at around the max power here, which is about 4 watts. Now it's down to about 1.5 watts. So if we go back to VCC int, I'll show you the core voltage. This is a -2 LE device. Right now it's running at 1 volt. I'm just going to change the scale again here. The -2 LE device is a special device that we create that we're actually screening from the fat part of the distribution. It's very easy for us to make these devices. It's just a matter of selecting them. So we had about 1.7 watts. When you change the voltage here, right now it's at 1 volt. Now I press this button, it's at 0.9 volts. You see about 20% savings in dynamic power. You get 50% savings on static power that's not quite displayed here in this setup. But when you're looking at worst case process, you get about 50% savings on dynamic power. This is showing about 20% savings on dynamic power in addition to the static power savings. If we go back to the original scale, we'll see how much reduction we really got using the features that are built in to the 7 series devices. It's about 4 watts, 4.5 watts, down from 10 watts. It's over a 50% reduction, taking advantage of the features in the silicon and in the software. And to see the temperatures down over about 10 degrees. So taking advantage of the features in the 7 series devices and using the power measurement features of the KC705 evaluation board, we're able to see a significant reduction in total power with the Xilinx 7 series devices.